Hello everyone, welcome to the second lecture for CS230. So as I said earlier, you can go on menti.com from your smartphones or your computers and enter this code 845709. We will use this tool for interactive questions during the lecture, and we will also use it to track attendance. I'll add it at the end of the lecture, but if you have time, do it now. Let's start the lecture while you guys are doing that. Okay, so today's lecture is going to be about deep learning intuition, and the goal is to give you a systematic way to think about projects, everything related to deep learning. It includes how to collect your data, how to label your data, how to choose an architecture, but also how to design a proper loss function to optimize. So all these decisions are decisions you're going to have to do during your projects. And we'll try to give you here an overview of this systematic way of thinking for different projects. It's going to be high level, more than other lectures, but we hope it gives you a good start for your project. We'll start with a 10-minute recap on what you've seen in the first week about neural networks. So as you know, you can think of machine learning, deep learning in general, as modeling a function that takes an input that can be an image, a speech, a natural language, or a CSV file, give it to a box, and get an output that can be classification. Is it a cat? 0. Is there a cat on this image? Output 1. Or is there no cat on this image? Output 0. And I think a good way to remember what is a model is to define it as architecture plus parameters. Architecture is the design that you choose. So logistic regression is the first one you've seen. You will see shallow neural networks, deep neural networks, then you will see convolutional neural networks, and recurrent neural networks. So these are all types of architectures, and you can choose to make them deeper or shallower. Parameters are the core parts. They're the numbers that make your function take this cat as input and convert it to an output. So these are millions of numbers, and the goal of machine learning, deep learning, is to find all these numbers. So we're all trying hard to find numbers, basically, millions of numbers in matrices. If you give this cat and you forward propagate it, so you propagate it through the model to get an output, you will have to compare this output to the ground truth. The function used to do so is called the loss function. You've seen an example of a loss function this week. That is the logistic loss function. We will see more loss functions later on. Computing the gradient of this loss function is going to tell you how much should I move my parameters in order to update, in order to make the loss go down. So in order to make this function recognize cats better than before. You do that many, many times until you find the right parameters to plug in your architecture. You can then give your cat and get an output. What is very interesting in deep learning is that many things can change. You can change the input. We talked about natural language, speech, structured and unstructured data in general. You can change the output. It can be a classification algorithm. It can be a multi-class algorithm. I can ask you, give me the breed of the cat, instead of asking you, give me just the cat, which makes the problem more complicated. And it can also be a regression problem. I give you the cat and I ask you, give me the age of the cat, which is much more complicated again. Does that make sense? Okay. Another thing that can change is the architecture. We talked about it earlier. And finally, the loss function. I think the loss function is something that people struggle with to understand what loss function to choose for a specific project. And we're going to put a huge emphasis on that today. Okay? And of course, in the architecture, you can change the activation functions. In this optimization loop, you can choose a specific optimizers. We're going to see in about 3 weeks all the optimizers that can be Adam, stochastic gradient descent, batch gradient descent, RMS prop, and momentum. And finally, all the hyperparameters. What is the learning rate of this loop? What is the batch that I'm using for my optimization? We're going to see all that together, but there's a bunch of things that can change in this scheme. Any questions on that in general?